Today we're looking at section 7-5. We're learning about sample spaces. Our goal is to be able to use lists and tree diagrams both to construct a sample space. So a sample space is a list of all the possible outcomes. Up here is a sample of a tree diagram. And this is a tree diagram for tossing a coin 3 times. So the first toss, you get either heads or tails. Okay, once you roll it, let's say you get tails, then you get to toss the coin again. And you're going to either get heads or tails again. And let's say we got heads this time. Then we still toss the coin again and we can get either heads or tails. So this part right here is a tree diagram. And this right here is a way to list sample spaces. So these are the 2 different types of sample spaces that we're going to be looking at today. All right, so the sample space for a number cube can be written as a list, and that list would consist of the numbers 1 through 6, 1, 2, 3, 4, 5, 6. Those are the sample space. That's a sample space for the possible outcomes of a number cube. Tree diagrams are a graphical way to show all the possible outcomes. It uses the branches to show all the different possibilities. The number of branches at the end indicates the number of possible outcomes. So the branches at the end indicates the total number of outcomes. So in this example here, we start by flipping a coin, and our coin can land on heads or tails. And then after that, we roll a die, or a number cube. And there's equal opportunity to land on each number in the number cube. So we have heads or tails, and when you land on heads, you can still roll any number 1 through 6. And the same thing with tails, any number 1 through 6. So there are 6 possible outcomes on heads, and 6 possible outcomes for tails, which means we have a total of 12 possible outcomes. We can also use tree diagrams to determine the probability of an actual event. So Lexi spins a spinner and rolls a number cube. What is the probability that she will land on blue and roll an even number? Okay, so if we use a tree diagram, we can write in our possibility for red, blue, or yellow, and we have 6 different possibilities with each number cube. Like so. Okay, so we want to know the probability of landing on blue and rolling an even. Okay, so here's landing on blue, and our even numbers are 2, 4, and 6. Our total number of outcomes, we have 6 here, 6 here, and 6 here. So our total outcomes are 18, and our favorable, being the blue and even, are 1, 2, 3. There are 3 favorable. So we're looking at 3/18. And if we simplify that down, we divide each side by 3, that gives us 1/6. So there's a 1 in 6 chance of landing on blue and rolling an even number. So now it's time for you to try. Sonic makes wacky packs for children, and they give them the option of choosing an entree, a drink, and a side. The entree choices are chicken strips, corn dog, burger, or hot dog. The side choices are fries, tots, or apples, and the drink choices are milk, chocolate milk, juice, or a fountain drink. So we need to create a sample space of Sonic's options. You can choose to do this as a list or a tree diagram. And then the second part is to tell me what the probability is of choosing a meal option with tots. All right, go ahead and take a go at it. and you can come back to the website and check the answer key. So this is the sample space for the Wacky Pack. You can see I've listed here all of the burger options. You can get burgers with tots, and your tots can come with milk, chocolate milk, juice, or fruit. Burgers with fries, milk, chocolate milk, juice, or fountain drink. Burgers with apples, milk, chocolate, juice, or fountain. So I did that with the burgers, I did that with the corn dogs, I did that with the hot dog, and I did that with the chicken strips. There are 12 combinations for each entree. So 12 combinations on the burgers, 12 with the hot dog, 12 with the corn dog, and 12 with the chicken strips. So that gives us a total of 48 possible outcomes. So for the second part of the problem, it says how many different combinations have tots? What's the probability of getting tots? So perfect. So these are all the burger and tot combos, the corn dog and tot combos, the strip and tot, and the hot dog and tot. So for each different entree, there's 4 different combinations with tots. So 4 combinations times 4 entrees is 16 possible. So your likely outcomes are 16. So 16 48ths is the possibility of getting tots, which is equivalent to 1/3. So you have a 1 in 3 chance of ordering a combination that includes tots.